I'm Mirko Bonfanti, I'm a PhD research student at UCL in the Department of Mechanical Engineering, and I'm also a Marie Curie trainee, and I'm at the third and final year of my PhD, so almost finished. And my research is in computational fluid dynamics applied to aortic dissection. Yeah, there are ethical issues because in order to use clinical data we need an ethical protocol that has to be approved, and in my case this has been taken care of beforehand, so for me it was easy to use this data that were already obtained. And in the future, if other people want to use this data, probably we will need to amend and modify this original ethical protocol. My research is basically on computational simulation, so we mainly use the computer. And the main method that we use is computational fluid dynamics, which is the simulation of basically any fluid that could be liquid or gas, because the equations are always the same. But we apply this computational fluid dynamics to a specific problem, that is the blood flow in a specific vascular condition, that is aortic dissection. With computational simulation, we are able to build a virtual surrogate of the patient in a computer. In this way, we can try on the computer, that is not the real thing, like different strategies, different treatment techniques, and make sure that this works before going on the real patient. So this makes sure that the treatment will be successful for treating the real patient. One of the drawbacks is that these are novel techniques, so they need validation and verification, and sometimes it's not that straightforward, because working with the clinical data are often noisy and incomplete, so it's difficult to validate our simulation with actual data. For my research, we use commercial softwares. For example, the main software that we use is ANSYS CFX, that is a commercial software for the computational fluid simulation modeling. Another software that we use is an image processing software called ScanEP, and we use this to extract the geometry of the aortic dissection from the images of the patient, in particular from the CT scans. The main focus of my work was to understanding the level of complexity that these computational tools have to need in order to be reliable, but also to be useful in the clinic. We don't want them to be too complex that are so prohibitive in a clinical context. And this allows us to develop simplified methods that are able to get good results, but still in a more efficient and easy way. One of the limitations is the validation of the simulations. In order to do so, there is another PhD parallel to mine, that is development of experimental tools, in particular in vitro mock circuit, that we will use also for the validation of my results. So this will be a combined approach, combining in vitro and in silico tools, in order to better understanding the problems and giving better solutions.